Welcome everyone to part 1 in our series of how-to videos on the INDICIUM DataBus. For help in getting started and to find out what you can do with your databus, go to our website at databus.indicium.cloud for lots of helpful tips and information. Now let's get integrating. Once you've downloaded the latest copy of the INDICIUM DataBus and put it on your machine, unzip it into the directory where you want to keep your installers, then open a command prompt to that directory. Then browse into the version of the databus that you've just downloaded. This is the version we've got here to play with today, which is version 1.8.0. Once you're in that directory, we can start to run some commands. Now the first command we'd want to run today is databus -, and this command brings up all these subcommands that we can use from our command line interface. Before we do anything, we need to create a database to store all our config in. So let's run the create database command and check its help. So we can see under help here that we can set a connection string and also specify the name of the database. The connection string will default to an integrated connection to the local server. The database name needs to be set, so we have to run that. So let's just run databus create database -d databus. That has succeeded in creating a new database for us. That database, if you were to log into SQL Server Management Studio, will be empty. So we now need to populate it with the latest tables and configuration. So let's run upgrade database. Now that hasn't reported any errors. It has successfully upgraded the database. We now have all our tables for the databus configuration and authentication configuration. It doesn't yet have any usernames or passwords to allow us to log in. So the next command we want to run is the databus. Let's just check our help again to get the right name. Databus default accounts. We'll run the help for that, and we can see we can specify a username. So I'm going to set trial@indiciumdynamics.com.au. Now this will create the default admin account with that username, and it will also create all the roles and other configuration needed for the system. So we now should have a databus that's ready to run. If we installed the databus pointing at a different SQL server, we will need to run, let's just bring up the help again. We will need to run a set config command over here to update the connection string. So if we run set config, you can see from this that we can use a -db flag to set the connection string. We can also change a few other settings as well as required. Now to run this on a Windows server, we have two options. We can run it from the command line, or we can install it as a Windows service. If we want to install it, we just need to run the databus install service command, And if we look at the help for that, we can see that we can override the username and password if we require, and that can be handy if we're using a database on a different server and we need to use a domain account to access it. If we've already got a service installed, we will need to uninstall it first. So there is an uninstall service option. If we just want to run it from the command line, we can just run console, and that will run it from the command line right in front of us. Once it's finished its startup process, it will tell us that it's actually listening on a particular port. We can see that it's listening on port 5000 for HTTP connections, and on HTTPS connections on port 5001. It will automatically redirect you to port 5001 if you attempt to connect to the unsecure version. Now that we have the databus installed and running, it's time to log in. Enter the default username that you set during the install process. If you chose the default option, the email address is trial@indiciumdynamics.com.au. Enter the password as well and hit login. You'll now be presented with the databus user interface, and the first thing you'll notice on this page is there is no license loaded. So first thing we need to do here is access the license manager and organize the license and update it. Your server token is something that you'll need to send to INDICIUM so that we can generate your license file. This is a unique token for each deployment, and you will need to use that for us to generate a correct license file to work on this machine. This link here will open up your mail browser with that token embedded in it to make it easier for you. Once you have requested a license and that has been delivered, paste the contents of that license file in here and hit update license. So now that we've done that, we can see that the license has been accepted. We can see the valid dates, and we can also on the right here see which plugins are enabled with that license. As you can see, we don't have anything configured yet, so let's get started. So step one, we need to create a new data source. Now for today's exercise, we're going to create a data source that reads data out of the WMI interface, Windows Management interface. So let's just call this WMI, and from the plugin list, let's scroll down to the bottom and select WMI. Once you've selected that, you can see a description pops up saying allowing querying of WMI using select statements when running under the .NET framework. So WMI will only work as a plugin if you are using the .NET framework version of the INDICIUM databus. Let's hit save, and we'll see the user interface changes with a few new features. The plugin is saved. It is possible to click the edit button here if you want, but that's something you need to do carefully, so we won't cover that today. And you can also see the URI, the identifier that has been created for this data type. There's a handy copy button here in case you need to copy it to put it somewhere else. We now need to use this data source to access some data. So we want to access data and input it into the databus. So that's where we get these input items. One handy thing that we can read from WMI is the current CPU usage of the server that we're looking at. So let's create a new input item down here. We'll call it CPU usage, and we'll click Add Input. You'll notice now that up the top here, these breadcrumbs will have navigated one to the right to show that we are now at the input item level, and we can see the name of the input item. Under here, in the input item details, we can add a description. We can change the data collection mode. and we can see the URI. Again, we have a copy function there if you need to grab a copy of it. The data collection mode is a very important feature. The mode manual lets you use the databus to collect data on demand. So that might be when displaying it on a dashboard. Interval lets you set a frequency such as every 2 seconds we want to retrieve the data. And then cron lets you build a cron expression for complex schedules. We've included a user interface so that you can choose exactly how you want to set this cron up. And when you hit save, it'll generate the cron expression for you. So that'll make it a lot easier to set them up. We'll just jump back to interval and we'll look at the rest of the settings. We can set a latitude and longitude. So if you did, for instance, want to record the location of the computer you're monitoring, you could do that. If it's an IoT device, then lat and long may make sense. It's possible to programmatically update these when it comes to IoT devices, but that's covered in another tutorial. Next we have the metadata section. So at the moment there is no metadata options to configure, but it's possible to add different metadata that we can edit. And last but not least, we have the WMI query itself. So this is a query we want to run to collect data about the CPU usage. If we hit this edit button along the end here, we get a list of examples that we can automatically use. These are examples where we've already figured out what works. So let's select CPU usage, jump back to the editor here, and we can see the command that it's generated. Let's hit update. We can now see it's saved over here. So now that we've done that, let's hit save input. And we've now saved all those settings, ready to go. We'll hit run now, and that'll let us test things. So let's test the input. And we can see some debug output on the left here showing what it was doing. If there's any errors in any commands, for instance, they will be outputted here. And on the right, we can see the current value. Now we want to set up a subscription. So a subscription is something that will fire once new data is received. We can have multiple subscriptions hanging off the CPU usage, for instance. So we might want to, for instance, archive that data to a database, or log it to a text file, or post it to a web service. You might want to do one of those or all three of those, and you basically create a different subscription pipeline for each activity you want to do. For today's exercise, we want to create a pipeline to put this CPU usage data into a database. So to do that, we need to create a new data source for a local database. So let's click New Data Source. Let's call it Local DB. And from the plugin type, let's select Local Database. And hit Save. We've now created a data source that lets us read or write data to the local DB. Over on the right here, you'll see there are no parameters for this data source, as it uses the inbuilt parameters for the databus itself. It's actually going to save the data in the database used by the databus to store its config. It's the simplest place to store data, so it's a good place if you need to quickly store something, do some work on it, etc. Next, let's go back to the home screen just to show what the home screen now looks like. We can see we have two data sources configured. Local database has 0 items set. We can come in here and see. And WMI has 1 item of which 0 are active. So we come in here and we can see CPU usage down the bottom, and it is currently disabled. If we enable that now, it will start reading that data on the frequency that we configured, which was every 2 seconds. Now let's just click on it and go into the details here, and we're going to create that new subscription pipeline to send the data into the local database. You'll notice now up the top our breadcrumbs have moved along to the right one more. So we can see we're in WMI, CPU usage, and the local database pipeline. Now we want to add an endpoint to our local database, and this is where we want our data to end up. We can choose to change the write mode, for instance. At the moment it defaults to append, but we could append replace or insert update. So the difference in these commands here is append will only add data to the end of the time series. So if the data is new, it will be appended. If it's a repeat of a point, it will be ignored. Append replace lets us replace any data that we find that exists, otherwise append it. And insert update lets us insert in between points if new points come up. Let's leave it as append. That's the most efficient way to store it. The maximum data age is the age of the data that we will allow to stay in the database. So every time we add a point, it will check to see if there's any old data and delete it. This is handy if you only want to keep, say, the last 10 days of data in your database to stop it growing too large. And the last item is the identifier. So the identifier is what ID from the data point do we want to use to store or to identify the data in the database. The default is input item. That refers over here to the identifier used at this point in the chain, but we can choose to change it to the output item, which is all the way over here at the end. This is the most identifying identifier for this data, and there are reasons why you'd want to use this identifier over this one, and that would be in case you're storing different streams of the same piece of data into the database. So you might want to store the CPU usage in its raw form, but you also might want to aggregate that as a 5-minutely data and store that in the database. So if we wanted to aggregate that data, for instance, we can add aggregate here into the pipeline. So the pipeline works top to bottom. We'd first aggregate the data and then store it in the database. The aggregate plugin allows us to choose how we aggregate the data. So instantaneous on boundary or average on preceding interval are the current algorithms supported. And it's going to do that aggregation at a 5-minute time step and then pass that into the local database. We don't want to do that right now, so we'll remove that and we're going to hit save. If we jump back to the input item now, we can see that the local database item here is disabled. So let's just enable that. Now that we've plumbed through our live WMI data into the local database, let's have a look at how our local DB configuration has changed. Now you'll notice down the bottom here we now have a CPU usage entry that has been automatically created by the databus. If we click on that, we can see that it's automatically mapped through to the URI of the WMI CPU that has been stored in the database. And let's just set with that a period of data retrieval. Let's just say today and save that. And now we can come in here and test the input. And now we can see under here that it has retrieved all the data available for today and put it in a table. So that shows the data has been collected and archived to the local DB. Now let's set up a simple dashboard that will let us display the real-time WMI data and the historical data from the local database. From the administration menu, select New Dashboard. This will display a blank dashboard. If we hit the cogs over here on the right, we can give it a name and hit save. We can now enable editing and choose to add some widgets to the dashboard. So we're going to add a real-time widget and a historical data widget. And we're going to add a free text widget as well. Let's just close that down there. Under the latest simple widget, which is a real-time widget, we'll hit the edit button and we'll choose our real-time data feed, our WMI data. We'll give it a name, set the units, and then configure some colors and icons to show. So let's choose some thermometer icons to show to represent the amount of the value of the CPU. Let's choose 0 to 50 will go orange and half full. 50 to 100 will be full. On the chart over here, we'll edit that, we'll give it a name. We'll make it show the last 1 hour of data. We'll make the dashboard go full width, so we can put a number in here between 0 and 12, which are bootstrap widths. And we can set the height of the widget as well. So we'll just make it a little bit taller at 250 pixels. And we're going to choose local DB CPU usage, the historical data as the data set to display. You can add multiple data sets to the graph if you want, but we've only got one in this system at the moment. And we added a free text widget as well, so let's edit that. And let's put some content in here. Just make something up. Okay, the free text widget can be customized with your own JavaScript if you want, but we won't do that today. So let's close that. Let's hit save and turn off editing. We can see some things have automatically updated to work. The free text widget, for instance, but we're just going to refresh the screen to get the dashboard working. And there you go, we have live data on the top left and historical data in a graph on the right. Now these dashboards are designed to fit different size devices, so if you do scale this down to an iPhone or a tablet, it will automatically adjust the size of the screen to fit.